Romania. Hell yeah.
Hello, hello. Oops. Hello, everyone. Probably I am too loud. Yeah. Hello, everyone. Welcome to Frontier Interfaces Hackathon. So you made it. You passed all the workshops that we organized for you. You learned a lot of new things, and now it's finally a time to dive into solving something really hard. Some really challenges from the companies. This event features see-through technologies, DisplayX, AI to AI, Emotivate, and we will also have a visitor from X Double Point, currently our engineer. So let's quickly just refresh a bit about the timetable. Right now it's opening. I'm just repeating some of the details that you should know so that we don't have questions later. Then we will have opening by Aaltoes Interfaces Lab Christian. Then we will have a Emotivate, DisplayX, and the companies in this order. And then the registration starts right after the stage program ends. You're gonna select the challenge that you're gonna solve and confirm your team members. Yes. What are the challenges? We made some small adjustments to the challenges. For example, the first one, storytelling by biosensing and sensors right now in Touch Designer. So right now it's allowed also to use Arduinos, Raspberry Pi, and other sensors and implement it in the Touch Designer. So you can do some button clicking behaviors. We will provide all the components for you. So it's not just Emotivate right now. And then we did a modification to the track number 4. It was accessible control, but now it's alternative. So it's any other control that is not yet in use. And that is where the newly joined company, Palo, is going to be. So they will talk a bit about their technologies later. What else? So the hackathon is organized by Thinkin Rocks, and it's in a collaboration with Future Interfaces Lab. Without them, this event wouldn't be possible. And we have, at first, I will talk about something new that probably not everyone saw in this room. We have a new project by, we have a new project making ambitious hardware projects. So we are bringing the most ambitious and technical founders. We support them with technical support and with the hardware and providing them a space. You can apply to it. I thought that there is going to be a QR code, but for some reason it's missing, but it is just /apply, a link, thinkinrocks.com/apply. And this event also wouldn't be possible, not only without Future Interfaces, but we are also supported by Eloven, Vihari Foundation for this event, and Red Bulls. So, yeah, maybe some applause to the sponsors. And yes, all communication, if you have any questions anytime, you can just sign up for this hackathon chat. It was before the team finding chat, but right now it's going to be hackathon chat, and you can ask all the questions here if you have any technical difficulties. But right now, let's already move on to the companies themselves. If you have any questions about challenges, you can ask directly organizers about formulation, and we can also give you some hints. Yeah, and the first
I'm sorry. The link takes you to the original Thinkin Rocks group.
Yerjan. Oops. That's okay. Like we will fix it and we will show it again in the chat. Now let's move on. The first representative is Aaltoes Future Interfaces Lab. I invite Christian on the stage. Yeah.
Turn it on.
All right. So good afternoon, everyone. So it's really great to support this initiative. I've been at the sort of frontiers of interfaces for a long time, and when we started discussing, I'm an executive in residence here at Aalto, and working with the team in Tuta when we're building a lab to look at future interfaces, and that's interfaces in a broad sense. It could be man to machine, but it can also be machine to machine. Anything that shapes our relationship with smart machines, and we try to build a sort of loose ecosystem, both with corporates. We're creating some courses, so we have an AI agent course that students can sign up for starting now in period 5. But I want to share a few things. I think I've been in a way interested and at the frontier of tech for nearly 40 years, and I think this is a moment where we're really moving from dumb tools to tools which we can really partner with, and I think this is an absolutely transformational moment in time. And I was sort of looking back to for some of you, that what inspired me when I was a bit over 20 years old. It was this video called The Knowledge Navigator, and I don't know if, has anybody seen it? No. So this is a sort of seminal video, and I managed from Apple to get a copy on a VHS tape, and I was showing it at my university to everybody who was interested, and say, hey, look, this is the future. And through many moments of serendipity, I managed to help shape one part of the computing future in building the first Nokia smartphone user interface, the Series 60, and I was extremely happy to see it on the cover of The Economist, and this computing's new shape. This title, in a way, still is haunting me, and so then some 14 years ago, I had a view that I have to prove to myself and others that I could actually build something from scratch. And at that time, I thought that wearables is going to be a big thing. Back in 2012, we then created these type of visions, and we decided to call the company Koru, and Koru means jewelry in Finnish, and then we built an operating system. And here again, we were working on the frontier of technology. So we had Ambic's dev boards, probably first in Europe. We had Qualcomm's dev boards first in Europe. And most of the time, the hardware didn't work. But then when we were working with the Qualcomm engineers in San Diego, and you had the chief designer of the processor on the other line, and our tiny team here in Otaniemi, you knew that you were really on the vanguard of things, and we then eventually had more than 60 million wearables built on top of our platform, and eventually my company then got acquired by Google. So now I think this era that we are in, and all of you, when you apply for a job, you're gonna come and say, hey, you get 2 or 3 for the price of 1. So you come with yourself, your brain, and your 2 agents, and apply for that kind of job. And if you are truly fluent in with your agent team, then getting a job is not going to be a problem for you. But there's one thing that I think is extremely important. It's always shaped my career, and this is sort of what I think what I want to sort of give back to the students at the university is things that cannot be turned into algorithms, namely what I call the human primitives. So curiosity, creativity, and courage. And to build and work these sort of mental muscles, I think, is something that you should all work on. And you know, it is everyone's superpower. And my mother gave me one of these Curious George sort of books, and I don't know whether that was sort of the spark for curiosity, but I've always been a very curious person. And if you are by nature shy, then just ask questions, because then you are, you know, you're not revealing any insecurity, but asking a question, you know, there's no bad and dumb questions. And then, you know, creativity is really about willing to learn and trying new things. And that's what we are, of course, doing here at the Frontier Interfaces Hackathon, is to be at the bleeding edge. And at the bleeding edge, things don't work. That's just the default. So you need big ass muscles, you know, to have the persistence to work. But be always, you know, curious and creative. And then lastly, the final one is about courage and you know, setting lofty goals, and then also exposing your own imperfections. You know, everybody will realize that you can't know everything, but it's okay to be imperfect. And I always felt when I was working with my engineers over the decades, I always felt like I'm the dumbest guy in the room. But I always sort of, for some reason, always put my ideas on the table first. And they were mostly crap. But I felt anyway, over, you know, decades of putting my ideas on the table very early, I got a batting average, you know, of 52. So 52% of my ideas were great, 48% probably crap. But at least then we got a conversation started. And once you have a conversation started, you can start, you know, improve and evolve. So my carrot and is sort of this hackathon prize is that we'll give to the 2 best teams, we'll give 500 per team who is displaying curiosity, creativity, and courage in this hackathon. And that's why I want to sort of emphasize that, how important these, you know, human primitives are in your lives, and you sort of embrace them and make them, you know, your superpowers. So thanks a lot.
We also are going to have 2 more prizes of 500 euros from Verkkakauppa gift cards from the Thinkin Rocks site for the most technically interesting projects. So it was supposed to be 1 prize per challenge. So let's see. And we also have something recorded from Emotibit, straight from the USA. They have some recording for us that they did for the hackathon, because I actually approached Emotibit and said, hey, we have your devices, we want to try something with them. Do you have any ideas in mind? And they were like, oh, maybe something about storytelling. And then we connected to Touch Designer ourselves. And this is like their kind of way to show support. Alex, there is the button. I'm sorry, Alex.
Don't worry.
No, it goes from a laptop. Okay.
There's technical difficulties of the day.
It's okay. I can do it from the microphone, I guess. Oi. It just died. Like, I can't press any button. No, it just doesn't work anymore. Yeah.
Hi, my name is Sean Montgomery. I'm the founder
It's
of
very-
Aaltoes, and I'm super excited to be a part of the Thinkin Rocks Hackathon. What you're doing is exactly why we created Aaltoes, to democratize biometric sensing and make it possible for more people to ask more questions about signals from the body. Let me take a minute to talk about Aaltoes and what you can do with it. The motivation for our work at the highest level is that internal context matters a lot. Everything we do, whether it's driving a car, taking better care of our mind and body, or simply having a conversation with a colleague, hinges on our own internal context. I have 2 young kids, and I've learned many things from them, but one thing I've had the opportunity to learn the hard way, again and again, is that when my 6-year-old is melting down because she's hungry, it's precisely the wrong time to have a belabored conversation about fairness in a family. It's time to focus on getting the girl some food. And I think this is an example of what's really true for all of us, all the time. Internal context is critical for everything we do. In fact, we know from neuroscience research that your internal context affects how your senses are perceived, how perceptions are integrated into judgments, how you react and your reaction speed to sensory information, and it also impacts your memories. Basically, it affects every aspect of your interaction with the world around you. And if we look at the application space for internal context, it quickly becomes apparent that it touches every sector of the economy in powerful ways. From individualized medicine to safety and comfort of transportation, to sports, education, entertainment, and advertising, internal context is the key to how we experience and react to the world. I suspect that much like the way we use GPS location data today, ubiquitously to find information that is relevant to our local city, in 10 years, biometrics and affective computing will help find information that is relevant to the current state of our bodies and minds. We brought several important principles to designing Aaltoes. We wanted it to pick up a constellation of high-value signals from a single location nearly anywhere on the body. We wanted it to be easy to use, open source, and have the data 100% owned by the user to allow more people, ranging from researchers to artists to students and personal health enthusiasts, to ask questions about their bodies and minds. And to make it accessible, we wanted to keep the price point as low as possible to permit more voices to be part of the conversation. For the Thinkin Rocks Hackathon, we're also running an exclusive 10% off discount if you use the coupon code TR2025 in the Aaltoes shop through the end of May. We've been happy to discover that many people were waiting for Aaltoes to unlock novel questions about the body. Launching on Kickstarter, Aaltoes quickly became one of the top 2% all-time Kickstarter campaigns and has gone on to generate over $1 million in sales to more than 60 countries worldwide. Under the hood, my company designed Aaltoes to utilize high-quality research-grade sensors. I'm going to fire up an Aaltoes and give you a live tour of my biometrics while I talk about the different signals. Here at the top, you can see my PPG, which is measured using a gold standard sensor that can derive heart rate, oxygen saturation, and many other metrics. In the raw PPG, you can actually see my individual heartbeats as oxygenated blood rushes through my capillaries, and algorithms can be used to drive heart rate, as is shown down here in red. Emotibit measures a wide range of skin conductance, shown here in the EDA signal, which are sensitive to changes in the sympathetic nervous system. So every time I get excited or nervous, you'll see a spike in the EDA, which often happens when I'm talking about Emotibit, but can also be triggered if I smack myself in the face. Ouch. You see, after a short delay, there's a big bump in the EDA, and that bump can be quantified with derivative metrics to indicate how big my anger response is. Skin temperature is measured with a medical-grade thermopile to reveal health and emotional changes, and IMU data provides a way to measure movements, as well as deliver sensor fusion possibilities for artifact correction algorithms. By writing data to an on-device SD card, providing open access to additional device pins, and piggybacking on the Arduino-compatible Adafruit Feather ecosystem, we tried to create a device with a lot of flexibility and adaptability to ask whatever questions matter most to you. The physiological data gathered by Emotibit has also been scientifically validated with gold standard research-grade devices in an article published in 2024. So who uses Emotibit? Emotibit users cover a broad range, from researchers and educators to artists and DIYers. Researchers are currently the largest group, split between academic and industry. At the University of Nevada, Reno, where I'm affiliated, there's a group using Emotibit to study concussion, as well as groups in neuromarketing and other disciplines. We often discover how people are using Emotibit from social media, and it turns out Emotibits are being used to monitor body extremes climbing Mount Everest, as well as mental journeys in psychedelic therapy sessions. There are even groups at NASA using Emotibit to understand user experience through physiological reactions. And in general, Emotibits are being used in some of the best research and education institutions, as well as companies ranging from startups to some of the largest corporations in the history of the world. What brings these diverse groups together is a desire to better understand biometric data and how it can make a difference in our lives. As my company continues to develop the Emotibit ecosystem, we hope to keep lowering the barriers to entry for more people to ask more questions about biometric data and how it can help improve our lives. If you search for Emotibit in Google Scholar, you'll find studies ranging from neurodiversity and autism to physical therapy, VR, and AI. But this is the most important slide. What questions can you ask about signals from the body? How will you change the future with biometric solutions? I'm Sean.
I guess thanks to Emotibit, and we are going to share this video in the chat because the sound was so low, but we are very sorry about it, and we are going to share it. Yes, and next we have Dispelix. So let me just open it. Can you check that it works?
1, 2, 3.
I mean, the clicker.
1, 2, 3. Can you hear me? Yep. I will try to be a bit more loud compared to the previous video. So, and I'm not video, I'm live person. You can ask me any questions. So, my name is Mikhail. I'm working for Dispelix already for more than 7 years. So, it's been quite perfect, I would say, almost perfect 7 years, where I've been studying quite new technology for me. And I studied a lot, I visited a lot of countries, I saw a lot of demos, I tested a lot of devices. And, but now I will tell you a bit more about Dispelix General. So we are a company which is founded in 2015. So we are a startup which is out of the VTT. And we have more than 300 technology grants. We are a highly technical startup. And 60% of our staff is actually the doctoral degree. So they're all PhDs, so almost all. And we have more than 20 nationalities. Oh, I have my slides also here. So our main goal is to develop waveguides, which works for the normal or general life. So when we can use them at like everyday life. So that's why they should be quite efficient, they should be quite lightweight, they should be quite useful for the people. So the more about the company, so we are our headquarters in Finland, and we have a subsidiary in the United States. And now it is official that we are subsidiary of AC Technologies, company from Singapore. So thank you. I thought that there would be applause because it's actually like kind of happy story because we've been startup out of VTT and now we are acquired. Thank you. So our waveguides are used in AR devices, augmented reality. So what does it mean? It's basically the glass, which is in front of you, so you can see perfectly everything around you, but at the same time, you can also get an additional image in front of your eyes, so that you can easily see how, like, you can easily put some TV on the screen, on the wall over there, so, and then you will be able to see this TV. I mean, kind of this video in your glasses. So our technologies is not only about glasses, actually. So we are developing the waveguides, which can be used for the glasses, yes, but it also can be used for some extreme conditions. So where there's some devices which are called head-up displays, or so then we can put it in some cars or in some like airplanes, whatever. So and then they will provide you again additional information on top of the normal view of surrounding. So what is usual, the smart glasses or AR glasses from our point of view? It is some glasses which actually contain the battery, wireless connection, sensors, which actually most of you probably know how to deal with sensors. And there should be also light engine, which would help our waveguide to guide the image to your eye. And we also working on a way that the waveguides would not only work as just piece of glass in front of you, but also as prescription glasses. So some people, they really need it, and that would really like make their life much easier. So, and yeah, waveguide is the most important component from our point of view. So how the waveguide is working? Okay, does it work? So it's quite tiny laser, but well, hopefully you can see. So, no, what? Ah, okay, no. So we have a special nanostructures at area which called incoupler. So those structures are made so that they couple the light inside the glass itself. So we are going to have here 2 demos, which actually you are lucky guys, actually, because it was never in our history that we allow students to touch our demos. So this time you're going to be allowed to do it. So please do not break because the glass itself is a waveguide. So you couple the light inside this glass with special nanostructures. Then we have additional nanostructures which helps to distribute the light over the whole waveguide to direct it to your eyes. So, and then the special structures, again, nanostructure, so it's nanotechnology. The special structures, they outcouple the light towards your eye. So there's plenty of smart worlds, but yeah, I try to make it as simple as possible. If you have more technical questions, please, you are welcome. It just, once again, I try to make it simple. So, and, but as a company-wide, the best stuff that we really want to say that we really have our own software, so which really helps us to work much faster compared to our competitors, or have a much additional, so we have traditional algorithms together with AI implemented in the software, which helps us to design the best possible waveguides. So we are supporting LED and laser-based projectors. If you probably, it's quite difficult to explain, but the light in these projectors are different, how it goes. So we work with the glass, with polymers, with crystal substrates, and we can simulate and optimize very big bunch of parameters. And the most important, we can incorporate this tolerancing for volume manufacturing. So if you ever aware about what does it mean volume manufacturing, so if you run some part over the production chain and you expect the part should have like the hole in 10 millimeter, but in fact it will never be like this. It will be 10 plus minus 5 or hopefully 2 millimeters, but whatever. And this is so-called tolerancing. So we need to be sure that during production, all of our nanostructures will stay within nanoscaled sizes. So yeah, and that's why in our mass manufacturing approach, we choose so-called direct etching. So we make some lithography, and then this is actually standard semiconductor manufacturing technology that you can learn at this Micronova, just right here in Aalto University. So all of those technologies which we are using, they're also there, so you can go and try to learn yourself how it works. So we use the direct etching. It's when you basically make some kind of mask, and then you put the samples into the chamber, you do some etching, so you kind of destroy the mask, but at the same time you copy the structure of the mask towards the substrate, and that's how you make the nanostructures on the glass, which are not actually visible generally, so you almost cannot see them, but at the same time they guide the light for you. So, and what is actually additional importance that we are also holding the metrology and quality control. So we design waveguides, we validate how design works, we validate how, and the thing that it's still at quite early stage of all this AR stuff, because there is no any like available, there's some, but still there are almost no standards how it should work, what kind of measurement need to be used, and how we need to set up the power meter, whatever. So that's why we built all this bunch of stuff ourselves. So that's why we can now run manufacturing in high volumes. That's almost all from my side. Thank you. A small addition, just give me, please, you can come. But so right after this, when all presentations are done, so I will set up one demo, that room, to show how, when it's well aligned video and so on, how it looks like, so that you can then try to reach almost the same quality of yourself.
Thank you, Mikhail, for your presentation. Now it's like we are moving on to the see-through. Ah, okay. Yep. And here's a clicker. Yeah.
Okay, hi. I'm Christian from See-Through, and at See-Through we develop eye tracking and gaze tracking. And our challenge here is about the gaze-aware interfaces for real-time contextual support. Our company is really developing high-precision, low-power eye tracking for real-world use. And what that means is that we develop both the hardware and the software to meet needs of this kind of an everyday use for eye tracking. And the basic idea is really to increase the bandwidth from users to these kind of different kind of interfaces and agentic interfaces these days. See-Through develops eye tracking currently for wearable devices. You'll get the glasses here. We also do these ocular devices, which means things like microscopes and binoculars. And we also develop gaze tracking for different kind of XR devices and smart glasses, like, for instance, Dispelix could use. So why eye tracking? The eye is really the only visible part of our central nervous system. So it has a really direct connection to our brain and how we operate and what we do. And since all of what we see is actually an illusion created by the brain, we just really observe the world through this small area of sharp vision, which means that we need to constantly move the eye around and sample the environment and to really guide our attention to what we are trying to do when we are performing any task. So what we get from the eye is gaze path and position. So where the eye is looking at, first of all, from the eye's perspective, the eye tracking part, we get how the eye moves, and then when we map it to the environment, we get the gaze. And that tells us where the user is attending to, and the gaze path can be used for inferring intent and action, or attention, or even mental states. But it's not a really good pointer. So the first thing people do with eye tracking when they start doing interfaces is that, okay, I'll activate buttons by looking at them. And that works, but it's not really good use for eye tracking as an interface, because what we do internally is that we need to sample the environment all the time. So we're blocking that if we do this. And what we want for this hackathon is something more clever. So in addition to, or how the eye moves is actually, the eye makes fixations, which is when the eye stops and samples the environment, and then there are saccades in between fixations, which are these really quick jumps between locations when we sample those. And the fixations reveal when and what we are processing, and the saccades reveal these shifts in attention. We also get the pupil diameter, so the pupil changes size, and has a few functions. The first is to control the amount of light that goes into your eye, of course. So when the lighting changes, the pupil reacts to that. But the pupil also has this kind of attentional and emotional reactions. So when you're concentrating, or if you get scared or surprised, the pupil actually shows a signal that you can use. And then, of course, there are the blinks. So the eye keeps blinking, and one of the functions is to keep the eye wet, of course, physically, but blinking also can be used as an indicator of your mental state or your focus. When you're really focusing, you blink less, and if you are fatigued or really nervous, you start blinking more. This is just a quick demo about how gaze behavior differs in different environments. There are two guys here driving. The one lower down, he's driving in a race simulator, and the red dot there is the gaze point, and the upper guy is driving in downtown Joensuu during the winter time. And while both of them are driving a car, the task is really different. So when you're driving the race car at the racetrack, you really are concentrating only on where you're guiding the car to go next. So the next apex of the turn, and really guiding or aiming your car toward that point. Whereas when you're driving in Joensuu, you're looking at everything else but the driving. So you're observing the environment, you're looking at people in traffic, you're observing other cars, intersections, all of that, but never basically where you're going. So this gaze path can really tell us a lot about the context of use. So back to the challenge. The idea is that the attention is the new input. So we don't have this kind of explicit input of pointing at stuff, but the interface should really understand what the user wants. So to make these gaze-aware intelligent interfaces, the idea is to design the system so that you use the gaze data so that the user isn't even aware of that, but the computer or the AI or whatever is the part using gaze as the input understands the user better. So we widen the bandwidth between the user and the computer. And we really would like these to be implicit uses of the information and not explicit. So not pointing at stuff with your eyes, but somehow to infer the mental state from what you measure. For the challenge, we provided 3 sets of glasses and our software to control the devices and the calibration. And then there's also the demonstration software or kind of sample code to how to access the data easily. plus the API description, and then there's even a simulated case generator. Because there are only 3 classes, if there are more teams doing this, then you'll need that to develop your stuff. So the challenge is to come up with case-aware interfaces for real-time contextual support, and really think that from these command interfaces, you'd go into these comprehension level interfaces. Like Christian said here, we are the last generation to use dumb interfaces, so now it's your time to come up with something really smart. Thanks.
We will provide all of the slide materials later in the chat so that you can find this GitHub link.
Do you want to be part of a demo? I can ask you on the stage if we are doing a live demo. I can ask you on the stage if we do a live demo.
You can invite somebody else.
Okay, yeah.
I'm just afraid of this.
Okay.
Yes. Yes. It's certain.
How about the video? Was it possible to put the video from the website as well? The video from the website, was it possible to have that one as well?
You mean emoji?
The video from the website, was it possible to have that? Or maybe I can just tell them that they can watch.
Now we have a presentation by the company A2I, and it presents its technology, Pallo. Yeah, welcome on the stage.
Hello, can you hear me? Yes, nice to be here. My name is Henrik Terävä. I'm the founder of A2I, and I was just wondering, has anybody heard about Pallo before this event? There's 2. And then one thing I was thinking yesterday, I got this interesting idea that how many of you know where the Thinkin Rocks name comes from? Because I didn't either, but here is a small story about it. Well, I mean, everybody has been holding a stone, and it's something you like to hold, and it's smooth. And then if you make it a bit rounder, so it becomes a ball. And for centuries, the people have been making different games around the ball, or tools or something. It seems like it's a bit. Yeah, and then the question is that if the simple shape what we have developed, a ball, if you make it to communicate, you make it to sense the environment, and then you make it to evolve with a cutting-edge AI, so what would it unlock? And this is just something came to my mind yesterday, but it's like a Thinkin Rocks. And so what is it? So the Pallo is the world's first platform ball. What means that you have, for example, mobile phone, so you can develop apps on the mobile phone. But then on the Pallo you can also develop apps. But the interface is different. I mean, it's filled with different sensors. It's as far as we know, it's the world's most advanced ball, and it has a lot of different functionalities. And so even though it's made to be as easy to use as possible, so it's easy to approach, it's Finnish high-tech inside, so it's fully independent. I mean, the Pallos work by themselves. You can connect it to the cloud, or you can connect it to the phone or the computer, and it's fully programmable. And this is a bit like a tech side. So we have this like a Finnish-made product, which is like a smart edge hardware. So on top of that one, we are using a Zephyr operating system. So it has, I mean, you can have edge AI algorithms analyzing the data, and top of that is a Python layer. So what the ones who will be choosing this one, so I will show you how to program on the top of the Python layer, and you can use AI tools to develop apps on that one. And this is our interface. So again, we will give you the access to connect to Pallo. You can have the access to file systems and add files, audio files, and different Python files, and you can do actually coding from this system. And what features does it have? So you have 10 different things for the communication, for interaction. So the Pallo has it has a small display, 64 times 64. You can have like a smiley faces and different logos on it. Then it has a speaker, so stereo speakers. It has microphone. It has touch buttons and different gesture control. And then it measures. So one thing what we sometimes tell that Pallo does everything. It doesn't fly, it doesn't shoot lasers, but otherwise it does almost everything. So I mean, it can detect the voice. It has dual accelerometers and gyroscopes, and so it can detect the handling, how you're using it. And then it also has this environmental sensors. And if there is somebody in the audience, if you go on our website, i2i.fi, so there's a video explaining different features on the homepage. And if there is some, like 2 people with a lot of courage, they can come on the stage, we can demonstrate a small Pallo example. There is one. Is there anybody? There's another one. So this is, you can take this one, and you can take this one. So then this is like a duel. It's a Wild West game. So you are facing each other and looking at each other's hands, and then you put it here on the side like it would be a gun, and you hold it there, and then you have to point the screen basically towards the other player like that. So you can have it, for example, like that, and then you hold it there, and just keep it still. So there's a Wild West music coming out, and when it vibrates, you have to lift the Pallo up. And the one who is faster, it's green. You can try it again. So maybe he wants to take a revenge. Yeah, but the idea you can think like this Tamagotchi type of devices which communicate with each other, and you can do different like games around it. And our challenge is developing something which is really creative and something which is like cool. And here is another one. It's now in Finnish, but it will just explain what it is. Yes. Yeah, you can put it there. Yeah. But yeah, that's all. I'll be then explaining like everything. We have like for each team 2 Pallos. The plan is that there will be like possibility for 3 teams and like really nice prizes. Thanks.
Thank you very much for your presentation. Now we have the last Yamin from the X Double Point, currently acquired by Aura. Yamin, please on stage. I don't have your slides. Ah, okay. Ali. Yeah.
It was me. I was very late with it. You found them? Yeah. Do you need Hello, hello. Cool. All right. All right. Hi, everyone. I'll try to keep this short because the story of Double Point's pretty short on its own. You might have seen us in Aalto at some point. Maybe have you seen these booths where you can go and play a game and then win a prize? Like, has anyone, like, okay, you've seen that. Okay, some of you. Okay, some of you have. Okay, so you've basically taken part in our product testing. So we don't actually make the games necessarily, but we make gestures for smartwatches. So using the existing sensors in smartwatches to detect gestures like double tapping or swiping or pinching and holding. And the idea isn't just to do what, for example, Apple Watch currently can do, but it's to do things that previously no one thought was even possible. So things like pinching and holding and swiping, and then like swiping left and right. So yeah, there you can see the point and select and the scrolls and the swipes. These actually used to be GIFs, but anyway, I think yeah, you'll get the point. And also we brought some dev kits so that you can try it out as well. But yeah, so maybe here, since this is kind of a hardware hackathon, so I'll just describe a bit how we ended up doing software for wristbands specifically. So software for hardware. There was a lot of hardware in the beginning. So the first idea was that really it started with like, how can we create, like, wouldn't it be cool to create like a keyboard that you didn't need to carry around all the time, and it would just be a wristband that you could detect what your fingers are doing, you know, without something physical in front of you. You could maybe even subconsciously write your thoughts. Hello, Christian. You could subconsciously write your thoughts. You could communicate with your friends very discreetly. But there was no product out there that could detect hand movements. I mean, either you had to wear a glove like that, or you have to strap a camera, and there was nothing. There was nothing that you could wear all day and, you know, wash your hands and things like that. So I really just tried to build something for myself because I used a 10-finger typing system, and so I was like, okay, can you create a wristband that could detect which finger twitched, and then based on which finger twitched, just guess what the word was being, like, what was the word being typed? And at the time, a neural band like this didn't exist. So this is from Meta. They use EMG, so they measure the electrical impulses of your muscles to detect which finger twitched. That didn't exist, so we were like, okay, why not like try to make one ourselves that was based on this? But I had no EMG background, so I was like, all right, why not just knock on the doors of some people that do? So here, Ivan Vujaklia, he's, I think, down the road, and he has like worked on EMG for like over a decade, and we just asked, hey, we want to make a typing demo, just to try it out. Do you have some help? Like, do you have some advice? And he was like, well, hey, we have some prototypes that you could borrow. And you had to actually dip this in salt water so that it makes good electrical contact with your muscles. But once you did, we basically collected a bunch of training data on a keyboard to try and detect which finger was moving. And this was the lab that we were in. And I guess the point of showing this is just that if Thinkin Rocks did exist back then, we probably would have come here first instead of going there. So yeah, that was where the beginning, where it all began. And then we realized that actually you could, like, electrodes were a little bit difficult for all sorts of reasons. I mean, if you start sweating, the signal is different. Like if you move your hand slightly, like the muscles move to a different location, so the signal is different. And so at some point it became clear that if we wanted to make something commercially viable, we would need to start and like redesign things from the ground up, including like what hardware sensing principles are we going to even employ. So we tried to use this basic one where we shine light to the bottom of your wrists and just see how much light comes back. And if you adjust the LEDs sensitive enough, or the phototransistors to be sensitive enough, you can actually see like the waves that form on the bottom of your wrist when you move your fingers. So that's what we started building, and this was built at the previous design factory. So yeah, and then in the end, this culminated to like just me kind of writing things, and actually this was a video, so maybe I should show you guys a bit later. But yeah, you can type with your fingers just by twitching your fingers. And then the question was like, okay, this was a hobby project. Would this become a startup, or should it just fizzle out? Or what's the future of this prototype? And I decided with my middle school friend at that time that because it was COVID and we were looking for our next thing to do, that we would try and make this our first actual startup. But then the question is, who is going to use a wristband that could type in midair? Like probably no one at the moment. I mean, I'm not sure. Maybe some people at Aaltoes would, but in the rest of the world, maybe not. So we had to ask, like, okay, if we know how to design and make hardware to sense what we want, or at least if we have shown ourselves that we can learn it quickly, what would be the ideal thing that we would detect next? And so that's when we really started prototyping. So we had a lot of different sensing modalities, like here, like that one with like some copper pads in the white band, like in the middle on the right. That's like capacitive sensing. So you can imagine the same tech in your smartphone that could detect where your finger is touching. You just put that on a wrist, and it should be able to detect the contours of the wrist. But there's also IMUs, like and contact microphones. I think that one in the very middle, like it was listening to your muscle movements at your wrist. And we created a lot of things. So for example, up there, using contact microphones, you can actually detect what the hand is doing with the things that it's grabbing. So you could use sort of a regular plate as a remote control. So you could like drive a car with a plate, and then you can shift gears up and down by tapping the back of the plate. So you could like repurpose existing things into controllers. Over here, we have this same prototype that you saw before. You can use it to press, and you can measure how hard you're pressing on a table. And if you press hard enough, it vibrates to make it feel like you just pressed a physical button that vibrates. So yeah, you could virtually map any amount of buttons here, and if you just know where the finger was and how hard it was pressing, you could make it feel like a physical physical keyboard that you can modify on the fly. And here there's, yeah, you can of course also use this technology to doom scroll. So yes. So yeah, that was the beginning of Double Point. In the end, we decided that we would focus on smartwatches because we noticed that a lot of the things that we wanted to do could be a simple software upgrade or software download to the sensors that exist on most smartwatches already. So that we started on 2 years ago, and that was also one of the reasons why Aura thought it might be good to work together, because they have very similar sensors on their rings as smartwatches do on like inside them. And so the idea eventually is that not only could smartwatches detect everything that your hand is doing, but rings as well at a very low power budget. So yeah, that's our story with hardware. That is all. Thank you.
Much. We finished with our stage program, and now, as Mikhail suggested, like he's gonna be there in that room in the backstage, showing his demo in the booth. We also start registration, where you can, like, I'm gonna be sitting there just in a moment, and we will confirm your challenges and your final team members. Yeah. Yes, I'm gonna open the schedule, and you will see. I have too many files. Yes. So let's start the registration and also look at the DisplayX demo. taking it off?
Hey, hey. Can you hear me? One. Okay, the registration is started, so you can go to the backstage right over there to get your register, your team. Good.
Haven't do any research.
Oh, this way. Okay. You see, if you close one eye, you can see different part of the image. So, but this kind of configuration is used for us because then we can, I don't know if it's working or not, but still. Then, because you can really put different part of the image to the different eyes, and you can make 3D effect. So that's what you said. So if you just manipulate it, so if you just move it a bit like further or closer, then you can like make this alignment and so on and so on, and then you can make some changes. Yes, but your eyes, like your eyes, like they learn such a way that